Hi, everyone. Welcome and thank you for joining us today for today's webinar, 2025 Manufacturing Roadmap, Strategies for Thriving Amid Workforce and Marketing Shifts. My name is Natalia, and I'll be the moderator for today's session. In today's webinar, we will revisit our predictions for 2024. We'll assess how the year went compared to our previous predictions. We will discuss our predictions for 2025. What emerging trends do we think will shape the industry this year? And then we'll discuss some tips for how to navigate these shifts. And now I'm excited to introduce our speakers. First, we have Erik Mirandette. Erik is an accomplished leader with a diverse background in business, intelligence, and international affairs. As our Chief Business Officer here at Tulip, Erik oversees all revenue, customer, and ecosystem development teams, focusing on expanding Tulip's market presence and enhancing customer impact. Before joining Tulip, Erik served as a captain and special agent in the United States Air Force Office of Special Investigations. And then we have Eddy Atkins. Eddy is a manufacturing nerd at heart. He started life as a manufacturing engineer, then moved to consulting and worked with some large global multinationals on their operation excellence transformation agendas. He's been with Tulip for over 5 years and has led teams across customer success and Tulip's library. And now he works closely with our ecosystem alliance and technology partners team, bringing joint impact to our customers. So without further ado, I'd like to hand the mic over to our speakers.
Okay. Thanks, Natalia. Appreciate the intro. Eddy, I didn't read your bio before this. It's much better. I love it. Manufacturing nerd at heart. Can I claim that as well?
Yeah, definitely. For sure.
Folks,
you take that, Erik. Based on what I know, you meet the grade.
I meet the criteria, I hope. I certainly am. Folks, thanks for taking the time to join us this morning, this afternoon, depending on where you're calling in from, maybe this evening. We want to talk a little bit about what we said a year ago in terms of predictions for the next year, some of the trends that we're going to be seeing. We want to check in. Were we right? Were we not right? Then we'll take a look at what we see coming and our take on how to navigate some of the trends we see shaping the market here. So appreciate everyone's time this morning. And without further ado, let's just jump right into it. Okay, so this is what we said last year. We said we made 5 bold claims, and let's see how they fared. I think the first bold claim that we made about a year ago was that we see MES becoming an increasingly less relevant category. So Eddy, I don't know, a year later, what do you think? How did we fare on this one?
Yeah, I mean, I think it's trending in the right direction. Definitely see our like when I talk to customers, they're more worried about the impact they're generating. How can we generate impact? How can we solve a problem? It's not, oh, give me an MES. And I think probably at the industrial level, like people, that's what generally people are talking about. I wonder. I mean, do you still get an RFP on MES though? How many of those did we get this year, Erik?
Well, we get a bunch.
We still asking for MES.
Yeah, but I think we hit this one on the head, to be honest. It didn't happen in 12 months, but you look, MES has been around for a long time, and I think it's going to still be around as a concept for a while. But I would say in those RFPs that we see, the requirements are changing considerably, moving towards some of the things that we're going to be talking about a bit later. And increasingly, I'm hearing the explicit reference of I need an MES, or I'll hear I need to replace my MES from time to time, but I hear sort of a broadening of the definition there. So I think it didn't happen in 12 months. We knew it wouldn't, but I do think that we hit this one on the head.
I think so, and I think that leads on to the second one pretty well. Like, in those RFPs that we see, like openness, connecting to other systems. I think it's people want like the UNS. If people haven't heard of what a UNS is, what have they been following this year? Whether it's fully everyone understands what it is, we can talk about a bit later. But I think that the need and the want to have something that's going to work together, and they're not just going to have one system to solve their problem, is definitely what we hear a lot of.
Yeah, I agree. I think this is another one where we you're seeing the market move quite a bit here, and this is very much the talk. And I think for better, by the way, I think this is one that we as an industry, I mean, is really getting right. Now let's go on to the next one. We said manufacturers are going to leverage emergent tools to better contextualize their data. How do you think we did on this one?
I think I'm not sure people are getting there yet. I think it's there's a gap. I don't think there's like people would like to be using their data to really drive, but I mean, I talk to folks that still don't have transparency across their operations. In like they'd like to be able to see what's happening on the shop floor in real time in the cloud somewhere, and they're not there with those basics yet.
Yeah, I agree. This was a so. I think, good idea, but I don't think it's really taken off in the way that we had anticipated yet. And it's going to be a longer journey.
And I think the next one is similar. It's like really generative AI will empower the workers on the shop floor to do their jobs better. I think we all had very high hopes of after what we'd seen in 2023 and like the speed that OpenAI launched. But I think we're fair to say there's some valuable use cases. We can dig into those in a bit, but not really. Not like when I look at what some of our software engineers are using it when they're using generative AI every 10 minutes in their jobs. Like we're not seeing that at the shop floor level today.
Yeah, I agree. I think this is one where it basically happened everywhere else, and it's just now making its way to the shop floor. And then the last one, I think, is maybe our worst. Turns out that, so we said engineers are going to want to engineer again. Turns out they always did. It's kind of my observation. They did, and they will. I don't know. What do you think, Eddy?
Yeah, I think I don't know whether we'd say we're lazy. I think that came, when looking back, where it came from is there were a lot of messaging out there, like trying to reinforcing that engineers are reminding engineers that they were really engineers. Yeah. And I think when we look back over the year, they've always been engineers and they want to play and solve problems, but maybe now they're starting to let them loose again with new technologies.
All right, so let's get into a couple of other things here. So first off, we said, so a couple of double clicks on the topics we just mentioned. The first is about the movement with respect to the character with MES as a category. There's been a lot of movement. I think the most interesting thing that happened in the last 12 months here was from Gartner, actually, choosing to discontinue the MES Magic Quadrant, which is wild. It's been around for a long time. And I still see people, I think this is very relevant, people still lean on the quadrants when making purchasing decisions. But the fact that Gartner retired the MES Magic Quadrant this year is pretty interesting and pretty telling. They downgraded that to a market guide for MES. So I think that's one interesting one that certainly I think reinforces that first point we made.
And I think on the ecosystem, very clear across many spectrums that it's an important element that we're wanting to bring together. I think particularly when we look at see Hannover Messe, big story coming out about how open ecosystems and technologies need to connect and work together. And I think as our customers are selecting technologies, this is what they're asking for. They're asking, can you integrate with this service or this service, and can I get my data into another system so that I'm able to do the analytics and on top of it? And that's, I think, where the value comes for our customers. And this is a demand that we see all the time. And then, AI, I think surprised us. So this is some research, and where manufacturers reporting where they've gained value, what they've implemented, and many folks are saying, like manufacturers out there are saying that they have implemented and made cost savings out of implementing AI technology. When I work the shop floor, I don't know about you, Erik, but it's definitely not everywhere. But I think that I've seen good examples of taking maybe a set of where a customer's been recording a failure and how they've resolved that failure across multiple sites in multiple languages over maybe many years. They've got that record, and then the generative AI allowed them to lay on top of that, created into a searchable data set that they were then able to give as a tool to an operator that allowed them to solve problems much quicker. So I think that there are definitely some simple solutions that have been implemented and they've seen value from. I think these in the report here, the customers are the manufacturers are reporting across safety, across product development, maybe some of these use cases we would say are not the core shop floor use cases, the shop floors that we walk and where we want to see them think for this year, probably.
Yeah, I was, so we sort of have, like what's the boots on the ground, having walked through, I don't know how many hundreds of manufacturing shop floors I met with, I don't know how many people building all sorts of different products, from biotech to food and bev to aerospace and defense to, so on and so forth. I was surprised by the results of this analysis, the survey. It doesn't match what I'm seeing on the floor, but I think that you made a key point there, and I just want to double click it, which is, that's not to say that the technology isn't being leveraged to realize efficiencies, and they cite some of the different use cases where this is happening. But what the key point is, I'm not seeing it in the workflows of the people that are actually responsible for and running these operations, which I think is a really key point that when we think about forward looking, is worth double clicking. So speaking of forward looking, okay, so that's the 12 months ago when we had our crystal ball, how did we fare? And I would say not too bad, I don't know, not 100%, but not too bad. A respectable performance, maybe. Let's take a look at where we see things going in the next 12 months.
First, I think digital transformation is done. Maybe not done, but maybe old. Like, everyone has attempted, tried it. I think we need to go back a bit to the roots of continuous transformation. And I think that, like, this year is where really the technology can also get us. We can do this digitally, we can do this in the way that we want, but we can get to a really continuous transformation mindset. And I think it's going to happen this year. And I think it's going to have to happen for many manufacturers based on what we see with the economy, what we see with the workforce developments. So that's number one.
And number two, we see out-of-the-box point solutions, standalone technology being used to solve a specific problem, becoming increasingly obsolete in the next 12 months. I think this is, related to the first point here, where in a world of continuous transformation, where you're constantly improving, I think that you're going to see a steady and consistent decline of, let me pick the technology, let me pick the vendor, let me go ahead and solve a very specific problem. I think that as a trend is going to decrease.
And I think that we expand that again and build on what we again had around ecosystems this year, is that they're just going to become a prerequisite. Like, you are not going to be able to accept a future technology into your tech stack if you've got a rigid, hierarchical, linear system that's not flexible. So I think the demand for open ecosystems is just, it's not going to be, do you have it or not? It's really going to be it's going to be critical criteria for success.
And then picking up again on this theme of what's happening within the generative AI space, I think we're going to see a rise of purpose-built specific AI agents leveraged to solve very specific problems. The key point of differentiation here is not like a chat GPT style, open model where, I can say, what should I do if I get cleaning solution in my eye, and how do I bake a cake at the same time? But rather very specific models that are trained on specific data sets with the intention of providing very targeted and specific, highly reliable expertise, right? So I think you're going to see a refinement. I think this is also one of the reasons why you haven't seen a general uptake in the workflows of the people doing the work in manufacturing. But I think this refinement with a higher level of precision and more targeted functionality is going to increase the propagation of these capabilities within frontline operations.
And then I think that will grow to become, for the operator, a solution that they're using that has been composed by a process engineer, but augments their process. They when they go to work, they use a solution that just fits the job they have to do, how it guides them to do that job, maybe has an AI supporting them in the background, making some decisions automatically, but also bringing, where it's within some guardrails, bringing recommendations to an operator. The solution that the operator has is connected to the device, to the machine, and it's really a composed solution that is very augmented and natural to use for the operator.
Okay, so let's dig into these a little bit more.
So yeah, if we're like, let's start with the front. Digital transformation is done. Okay, we can challenge that, but I think really none of us are going to challenge that we need to be in this more continuous, constant transformation mode. Like, manufacturing geek at heart, I started my life on the shop floor doing lean type work every day. I was trying to improve processes, and that's what turns the blood of every manufacturer. And I think the first point here, if you're not continuously transforming, continuously improvement, you're going to be falling behind. And I got that banged into me in my first week, I think, as a manufacturing engineer, the plant manager every day saying, how are our numbers? Are we hitting them? What can we do to be doing better? Tracking actions, like really just driving many small improvements throughout the weeks. And I think as like talked about moving to McKinsey and doing transformational work there, we were working with our clients to build new, like going and transforming sites, but actually the core of that was implementing a continuous improvement mindset and helping customers really get into very solid iterative ways of working and making many small changes that add up over a whole organization. And I think something I saw as we moved into more digital and more industry 4.0 is that it wasn't possible always to iterate at the speed we wanted to. And I think now, like what I see with the tools and the platforms that are here today, this year is where we really need to reset our mindsets and say we can go back, we can do that continuous improvement that we wanted to for a long time in a really iterative way with the digital tech stack. And we don't need to try and plan some big transformational project. We can go and make lots of small improvements, compose them together, and have a big, like, all those small improvements will have a big impact.
And this is fundamental to, if you think about the very nature of how manufacturing operations work and very basic lean thinking and lean principles here, like this is at the core. And I think it's telling. This is a statistic we saw where, when leading manufacturers are asked, how many of you have started your digital transformation journey? You're not in the prepare phase. You're thinking about it. You're in it. You've taken action. And the answer is, most 2/3 or so. What is not reported in this analysis is how many have completed their digital transformation journey. But I can tell you anecdotally, based on the conversations I have with everybody every day, the answer is zero. Zero. Everybody started, or everybody starting. I've never talked to anybody who says we're done, we've completed it, mission accomplished. And I think that this goes back to the very nature of manufacturing. It's not a moment of transformation where you go from a before state to an after state. This is a process of continuous improvement that's never going to end. The difference is you're just now using better, hopefully better, but digital tools. You're using some of the modern tools and capabilities that are available to you, which are oftentimes digital in nature. And so this just becomes a way of working, as opposed to this kind of this chasm that needs to be crossed.
And I think this is not wherever you are in your digital transformation journey, if you're one of those 67% that have succeeded, failed, like somewhere in the middle, have had some successes, but not all of them, I think you can move to continuous improvement. If you succeeded, moving to continuous improvement will help you sustain the advantages. If you haven't started yet, continuous improvement, continuous transformation could be a good way to start with something really, really simple. And I think, there's a lot on the horizon this year, and like being in a place ready to react to those and as a manufacturer, respond to these quickly. We're going to have to have this mindset and use the tools around us to achieve that.
Okay, so our next prediction for 2025 here is that your out of the box solutions are going to become increasingly obsolete. And so let's talk a little bit about this. So let me go ahead and jump right into it. So I think when I think about the challenges facing any production environment, any frontline operation, I walk through any shop floor, and the challenges are many. They are varied. and they are dynamic, each of which have their own use case for technology. So you might be struggling with a production visibility issue. Where is this work order? You might be struggling with an inventory. You've got line down. Why is the line down? Well, maybe there's a material shortage. Maybe equipment has stopped. You've got an OEE problem. Maybe there's a training issue and a lack of standard work, and folks don't know how to. The point is, there are any number of things that could go wrong, or problems that need to be taken on at any given point in time. And if you dig into only one of them, there's a whole set of technologies out there that would address that specific problem. But what I want to posit here is that doesn't reflect the nature of the problem, really. My position here is that there's this kind of siloed way of thinking about technology and use cases is missing the point, and that these are in fact interconnected in overlapping in ways that are difficult to kind of pull apart. And so I think a more appropriate way to think of these as, if we were to take one, for example, let's take the production visibility use case. Maybe you're in a production environment, you don't know where a particular work order is or where BOM materials are at any given point in time. It's really hard to solve that problem and only that problem. It's really hard to not say, well, where does this start to overlap into my quality use cases, or if or my work instructions and guidance, or if I've got production visibility and I'm waiting for a part, well, wouldn't I also want to be able to activate an and-on light? So is that a separate use case, or is that the same use case? And the point is, it's not this set of unique, siloed, standalone, distinct challenges and use cases for technology, is as much as it is this mosaic of overlapping and interconnected use cases. Now, I would take it a step further and say that you can start to group these use cases together, and what you see is different categories of software emerging here, connected worker, or MES, or warehouse management system, or CMMS. Now, look, this is not by no means comprehensive, and you could poke holes in the specific illustration here, but the point is, conceptually, we sort of group these use cases together to define categories of software. But if you really try and separate manufacturing execution systems from connected worker platform, you'll find that there's no clear line. There's just this kind of sliding scale of gray in how you define requirements as applied to your specific operation. And I think that, by the way, this is one of the observations that Gartner is making when they retired the MES Magic Quadrant. I think that this is like a fundamental insight, which is like, look, the category has evolved, and it's no longer reasonable to think of this as a disparate capability. Now, if we take this a step further, if you take any of these use cases, they each have dependencies on data that exist elsewhere in the IT stack. So if we go back to that production visibility use case for a moment, there's no world in which you could solve that problem sufficiently well without incorporating data from an ERP system, as an example. What's my inventory levels? What's my BOM? What are my work orders? Like, what's the routing, et cetera? A lot of that's going to live in other systems within the IT architecture. ERP or QMS, the SCADA system, the control system, the PLM, the human resource information system. The point is, each of these different use cases have different kinds of dependencies on data that are bidirectional in nature. If you think about performance management and training records and work instructions and quality outcomes, they're all kind of connected, and you probably want to have this tied into your human resource information system. And this is why, by the way, if you approach each of these as a standalone, let me go ahead and buy only a production visibility or an OEE or a work instruction tool, and you're not thinking about the problem in this way, you're going to end up with a extremely fragmented IT stack, and you're going to end up in it's going to be a system integration nightmare, trying to configure which data needs to go between which systems and how. So to the extent that you're able to standardize this with common infrastructure that gives you the ability to field these use cases, this is an advantageous and better way of approaching this conceptually. It's a much more future-proofed and resilient way of taking on these use cases. And so this is our position and kind of the fundamental insight behind our second prediction for the year.
And Erik, this is like a very live topic that I'm having right now with a customer, where exactly they've selected previously 2-point solutions, one for their connected worker, one for their maintenance. And this is not, I think what's interesting, this is not historic monolithic solution that they've had for a long time. These are modern platforms, and they're working with, starting to do their pilots with them, starting to work with them, and they're able to achieve an improvement in those areas, and they're giving them benefits. But when they come to look at the full picture and say, can we solve all the use cases, the operator value cases that we want to solve, they find that they end up having another custom development on top of that platform to actually connect the data together, do the analytics, feed that back, and try and like one of the things they want to be able to do is actually change the route and the recipe that the operator is using based on what happens earlier on in the process, so they get an optimized and get an efficiency saving. They can only do that if they can actually change the work instruction almost live, or like the work instruction has some adaptability to it, and they're not able to make that whole closed loop, and there's a lot of plumbing needed to get the data in and out. So a very light topic. That's I think quite interesting to me, that this is not just about our, like when you've got a traditionally designed non-modern platform, but also some modern platforms are even still are locked down and not able, too rigid to be able to really achieve what manufacturers want to achieve.
Yeah. I think the point here is like the to your first point, the continuous transformation, the adaptability of these systems, and the more systems you have to be able to maintain and have to learn how to use, the harder that becomes. It's not to say that you must absolutely standardize. Like let's take warehouse management systems as an example. Many customers use Tulip as their warehouse management system. Many customers also have standalone warehouse management systems that are fantastic and do exactly what they need to do that connect to Tulip. And we don't have a position on one approach or the other. The question is, like, is it doing the job? But and if so, great. If it's not broke, don't fix it. But to the extent possible, be thinking about this in terms of like unifying architectures and core infrastructure, as opposed to cherry picking point solutions to address problems, I think is the key takeaway.
And I think, Erik, that moves us on quite well to the next one here. It's like, how can this, how does an open ecosystem, what is an open ecosystem? How does it make you future-proof what you're trying to build, and enable you to have that this sort of composable platform approach that you want to have? And I think we see it, like a lot of the data is there. It's how do you get access to it easily when you're building a solution. Like if we go back to this solution of trying to optimize yield on this process, when I'm trying to get the data that I need from the different parts of the process, from maybe the warehouse management system where the goods have come in, to the weigh and dispense where it's initially been weighed out, to the initial mixing process based on how that's run. How do I get access to all that data and then use it to actually make a change in the process? So we need to have, and if I'm trying to do that in a hierarchical way, in a linear way, which is pretty traditional, or in siloed systems, it's a tough thing to do, and a lot of re-engineering needs to happen. If we're thinking about more of the model like a UNS, being able to have access to data that's transportable and be able to have real updates to changes and some organization around it, I'm actually able to almost connect anything into my process and use it in an easy and scalable, future-proofed way. So I think this is on it, and like very clear, like beyond just manufacturing, but really, if we're wanting to do AI well and properly, we need to have good data, valuable data that's got good context. So that we need to have all the data that's available to us. And I think that's one of the key messages here is, if you are recording things, it's actually becoming very low cost to record all your data. Take what you're doing on paper, take what you're doing on a whiteboard, and having it in a space where you can actually collect it, start to organize it, and then have it accessible to an organization. And I think that will set you up very strong for using it in a AI and driving business critical improvements.
If I could just add to that, I think one of the things I've observed is the transition from of like, how are we thinking about data capture from, look, we got to capture all the data, we got to capture the right data. And then we have to have the appropriate contextualization around this data such that we can get some of these other benefits, and we'll open up the topic of AI again in a moment. But this is like on the ingest side, this is the prerequisite for, being able to get a lot of value out of those use cases. So I think that's a really critical point.
And I to build on that a little bit more, Erik, I think we've gone from you need just go and spend your time getting the data to get the data you need to solve the problem. I think I'd also add on there, like, at the same time, if it's easy, don't not collect the data as well. Like, you might need it later on. So if you like, it's not that expensive to you whilst you're there to collect the data, but don't spend more time there than you need. Otherwise, you're not continuously improving.
It's, if you guys, for the audience, if you've seen me on webinars before, I always try and incorporate some sort of like meme or GIF into my into these webinars. I spoiler alert, I don't have a great meme for you in this one. I tried, but the meme that always comes to mind when we have this conversation is like this. You remember that South Park episode where it's like they were like the tooth fairy gnomes or something, and they captured all the teeth, and like step 1 was get all the teeth. Step 2, well, we're not quite sure what step 2 is, but step 3 is profits. I always feel like I always like see that mental model when I'm like having conversations. Like, well, we got to capture all the data, and then then step 3 is it's gonna be super valuable. Yeah. We're not quite sure about step 2 yet.
Yeah, exactly. We maybe we can work in the background. I think we're not quite agile enough to add that GIF before the end of the webinar. Maybe as a follow-up.
Yeah, I'll email it to you if you reach out to me after the webinar.
And I think so. What we've seen with AI this year was it didn't quite meet all our expectations. It's not every manufacturing operator on the shop floor is not using AI in their process, and I think we ask ourselves why. I think one of the reasons is the same reason why not every process is digitized on the shop floor. Every process is unique. It needs to be dynamic. It needs to continuously improve. So we almost need to have something special for each process from an AI perspective. I think secondly, obviously being reserved to actually, do we feel safe deploying this AI on our data, in our data process? I think there's a third hidden thing that is not so discussed about, but is actually, I think it's become evident as people have tried, is the data quality, is it really good enough to do the job that we want it to do, which feeds back into the second point. And I think what we're seeing, the trend that we're seeing in other areas, and I think is coming to manufacturing, will be more specifically built models trained on, like, if you're trying to do a AI that's going to help you run your process, that large language model can be trained more closely on manufacturing documentation. So it actually understands the manuals that you're giving it better. It understands the SOPs you're giving it. It's much more tuned and honed to actually running that sort of data. In order to build those foundational models, the challenge is, like, how do we get this kind of manufacturers need to almost give their IP in order to build these foundational models. But we're seeing a lot of developments around how taking data, anonymizing it, customizing it, sanitizing it, and actually being able to use it in a way to build models that's not revealing IP. So I think that will be an interesting trend to see how that develops, to actually allow sort of maybe companies to build more foundational models that solve problems more specifically. So I think when we look at where it's going to apply and where we're seeing our customers ask for it, I think the data analysis part is really important. Like, you're generating big data sets. How can you use the AI to help you understand it, run queries very quickly? Like, bringing the manufacturing engineer no longer has to be no SQL to be able to do complex queries on the data analysis, and also being able to combine both the time series data alongside some image data, alongside the PDFs of the process and the reports. So I think very quite interesting to see where the actual insights generation goes. The development and deployment of solutions, whether it's actually the coding on a PLC or the actual building an app to go on the shop floor, like, we will see AI supporting actually that process. So this is the first two really are around, like, how do we democratize the process of putting that AI agent into the shop floor, actually using it, and then we will see it in the workflow of the operator. I think sometimes sitting in the background, running within some guardrails, maybe even making changes to the process. We're seeing examples of this already. We're talking this week to a startup that are deploying into data centers. They're actually deploying AI models on the cooling and managing the cooling and autonomously making changes to the cooling processes to save energy, to make step change improvements in the energy consumption. But then if they're wanting to make recommendations outside a particular bounds, that recommendation is getting made, shared with an operator who has to approve it. I think what was really interesting is actually that's quite complex, the changes they want to make and why it wants to make it. And that particular company is using Gen AI to actually generate an explanation of the changes that are being made and how they're being made in a human language. So it's actually quickly understandable for the operator to actually say, yeah, this is something we want to do, or no, it's not something we want to do because it looks risky. So I think that's going to be interesting to see how that really comes to the fore in manufacturing as well. I think
this is the point we made a bit earlier, right? Let me give you an example. We talk so many people have grown accustomed to, and by the way, there's a chat in the comment that everyone I fully agree. One, because it builds on the tooth fairy meme concept, which I think is great, and two, because we need to be specific, right? It's not like, hey, this is a cool capability, it's going to change the world, like let's all go celebrate. No. Specifically, what are the problems that this is going to solve? And that's where the value is going to be created. I think of this, we've become so accustomed to thinking of interacting with these models in terms of like a chat interface, and the output is either chat or some sort of like data analysis. But to talk about what this looks like in the context of a workflow, I was having a conversation with a customer a couple of days ago, and they were thinking about this additional use case that they want to take on. And they said, look, we're like at the workstation, we've got a part coming in, we want to see if it's a good part, bad part, and there's a visual inspection process. And I want to document the result of that visual inspection, so I have a library of these. So I can go back, and if there's a recall later on, I can go back and pull it up. Well, the next step is to say, well, if you're taking these pictures, you can run these same purpose-built specific AI agents on an image data set as easily as you can a text or a number data set. And so what they can do is they can start categorizing these, and and you can basically you can have a system that's autonomously telling you, hey, we took the picture, you don't need to do the visual inspection, there's a 99.9% probability that this passes, or if there's a failure, this is the kind of failure, and then start to incorporate that feedback loop further upstream into the source, like the root cause of the defect, to do some sort of preventative measure upstream. And then this is where you get it's the combination of being in the workflow and having human in the loop here, because you can say, what's a sufficient number? Do you need 10 images, and is 90% reliability enough, or do you need 10,000 images because you require 99.99% reliability? And these are a lot of judgment calls in the field in terms of how to employ these to solve that specific problem. So I think a really good point in the chat there. But I think we're running a little bit behind. I think we got to pick up the pace, Eddy. We're gonna run out of time here.
So now, I think finally to wrap this up, really, we have this sense like composability. So how is the frontline operator going to experience these solutions? And they're going to be, for them, the process engineer is going to compose something together that the frontline engineer is going to use. And I think we're going to really see a change in the way that the frontline is digitized. So, and this is like a trend I think we're seeing from Gartner here, really saying that 25% of the manufacturing operations will use a composable technology architecture. And that's a real step change from 3 years ago. So up from maybe 2%, they're reporting that. And these are applications that fit this continuous improvement way of working. And I think to the point around the AI, we will not see AI be a step change or suddenly have a full automated process, but it will come through like Erik said, we will deploy a camera to start taking images, and that will be part of the reporting, and there'll still be an operator in the loop. And when we could suddenly then develop a data set that we can train a model on, and we'll initially deploy the model in the loop, and then later on maybe the new model comes along that is actually better, more honed, maybe cheaper. We'll be able to switch it out, we'll be able to compose that new model in, and then we maybe feel confident that new model is actually giving us the power that we need, and we're able to give more autonomy to it. So I think we will see a continuous improvement in the way these systems are deployed and composed as well.
And if we take this sort of all the pieces that we've talked about and we extrapolate them out into the future into some sort of extreme state, this is Niels Andersen, who's I follow a lot of what he says. I think he's got a really interesting kind of thumb on the pulse of the industry here. And what he says is, in the long term, if you think about combining all of these different trends, this really AI plus these composable solutions built into the workflows of the operator, he's saying, look, this converges on some sort of like human HXI, which is like the operator's interface to all things via a generative AI chat agent. And I think that this is like this I think a few years ago felt like science fiction. Now it's like a pretty natural extrapolation of existing trends. That's not to say it's going to go this way or should go this way. But what we can't say is that it couldn't go this way. And I find this to, if we're talking about the last 12 months, the next 12 months, I think it's kind of helpful to look, what does this look like 5 years, 10 years from now, at least in terms of the realm of the realm of the possible. And then that gives us a sense of like, how might we want to navigate and influence this along the way. But I thought that this was kind of an insightful observation from Niels.
Yeah, I'm not sure we'll get to the chat interface for every operator to tell them how to do their processes this year. And I'm not really sure that's the right answer for manufacturing either, but we're already seeing, like you see the DMG Mori controller on the right hand side here, that this is running the core controller, but also built applications that are built on this, that running in the cloud, that connect to the device, local devices, can connect to, can be built in no code by a local process engineer as well. And this is very core to the work that I do with some of our partners here at Tulip, is spending a time to think about how can we use the machine, get a sort of another value for customers out of the machines that the companies have. And I think this is the sort of composable HMI, but where does this end? We're going to have the composable QMS, the composable warehouse management system, and maybe
we're seeing it in labs. We're seeing it all over. It's but this concept. The point is, I think that these concepts, these principles, aren't specific to one section of the operation. It's a sort of a general trend that has applicability across a wide spectrum of what we would think of as historically kind of niches. HMIs as an example, or LIMS, or LES, or so on and so forth. So. Interesting to see. So let's talk a little bit about our view on how to navigate some of these trends. And I think we'll keep this pretty tight and then go to questions. I think first, adopt a composable architecture. When you're thinking about use cases for technology and solutions on the shop floor, let's not think about it just in terms of what is the technology that allows me to solve this problem, but think of it more holistically as what kind of infrastructure and data architecture do I need to have in place such that I'm able to deploy technology in a very flexible, iterative, agile way to address these emergent challenges. The second, invest in data management here. It's not a matter of capturing all the data, going back to my tooth fairy meme idea. This is a matter of capturing the right data for the right reason with the right contextualization such that you can use it now and you can use it later. And then the third is these AI agents, they're becoming increasingly available, ubiquitous, cheap. You're seeing this in your inbox. You're seeing this in across the stack, with the exception of frontline operations. And I think that there's a lot of opportunity, in really driving this forward in the next 12 months. Okay, maybe a double click on the composable architecture concept here. This is just a visual illustration of, on the top, kind of the historical monolithic approach to implementing these systems, where you start by defining all of your requirements, you select a vendor, you build the perfect system, and then 12 months, 18 months later, you have this thing bolted to the ground. All code changes are frozen, and now this thing is up and running. Yeah, that's the way that the industry has consumed software, in a sort of a pre-agile mindset. I think the methodology or the way of thinking has evolved faster than the technology, right? So a lot of the systems, incumbents in particular, are still, from a software perspective, still deployed and architected in this way, as opposed to this composable approach, which is identify the problems, continuously improve, iterate, and then compose these solutions. In each of these little boxes, you can think of as not, a specific app or even a specific station or something like that, but rather a capability that addresses a very real pain point. The intention of which is that you would not set it and forget it, but rather this would be a part of your daily interactions, that you could continue to adapt these solutions in response to emerging requirements in your environment. And I think with that, maybe Eddy,
I think
we can end on this and go to questions.
Yeah, one last. I think on the AI side, we're seeing more and more technologies out there that are allowing this democratization of the AI, and I think this is what's going to power this ability to build these very local agents that can support by the people closest to the process. So excited to see what here are some examples, but excited to see what that looks like at the end of this year.
Okay. We've got about 10 minutes left. Thanks everyone for joining. Let's turn it over to questions.
So to start off, we have a question. Would like to clarify my understanding of Tulip. It is an online shop traveler system whereby the BOM for each operation can be driven by existing MRP systems. Data gathered within Tulip can then be customized, including resource allocation, analyzed for yield, reject Paretos. Is this correct? I think that's a good one to start off with. You guys can kind of give an overview of what is Tulip, just to get everyone on a baseline.
Yeah, so I would say this is certainly a common use case for Tulip, but that's not Tulip. I would reference that if we go back, if we think about the circles with the infrastructure, and then the IT systems below that, or other systems, they don't even need to necessarily be IT systems. You could see QMS being a part of the mosaic of circles, or WMS being a part of the mosaic of circles, or a piece of infrastructure that needs to be integrated with those solutions. Tulip is that layer of infrastructure, the platform that allows you to normalize the integration layer with your existing IT stack and field using low code, no code capabilities, use cases, and make them accessible to operations. So you can import them from our library. So these are standard best practices deployed all over the world. You import them from our library, you deploy them to the shop floor. You can think of these as like modules or set capabilities, and then you can adapt them, configure them using no code. And this process visibility is a very common core use case, but there's also all of the adjacencies. And the real value here is not necessarily in just addressing that one problem, but rather the flexibility and future-proofing you're giving yourself when you have a common set of tools that allow you to take on not just this, but also all of the adjacent and related use cases. Eddy, anything to add?
Yeah, I mean, I think just to get tangible there, so you might have this type of use case that's described here, but then at a station, an operator would look at a screen that shows them a video, maybe that how to do the process, that's connected to the devices that they're using to do the measurement, or the torque driver, so connected instruction that's error proofing that flow for that particular operator. But then maybe you go to another part of the facility where there's the CNC machine and you're doing the machining, and we're collecting the traveler data, but there also maybe we're doing the machine monitoring to understand what's the uptime of the machine and tracking when it is down, what's the downtime reasons, giving a startup checklist for the operator to make sure they start the machine up correctly and do their daily TPM. So it's all of these applications that Erik was showing on his or solutions that Erik was showing that can be built together on the same platform to create a digitized, augmented shop floor.
Awesome. So next question is, can you share an example of how composable and no-code development platforms enhance flexibility and speed in manufacturing processes?
I'll share one example that that came up recently. Tulip was deployed similarly. Think about that, the Venn diagram, the bubbles and circles. They said, hey, we need a quality solution. We said, okay, no problem. What's the problem? It's end of line quality inspection. This was an apparel manufacturer. They're making shoes. And they said, okay, so what are we doing today? It's like, okay, well, every item that comes off goes through a visual inspection. We inspect each of these points, and then we write that down on our form. And at the end of the shift, all of these are collected. At the end of the week, all of these are manually entered into Excel. And at the end of the week, we see every Monday morning, there's a report of all the things that went wrong last week. And they say, okay, we're going to do better this week, but the ship has sailed, right? That was the first use case, and very simply took and this is about incorporating the technologies in the context of the workflows. We just simply replace that paper form with a digital collection tool with the exact same questions, and then what you have is like real-time reporting, not in a week, but rather like real-time reporting of what's my defect rate by root cause or by defect type. And then from that, you can infer root cause. And so it literally, we didn't even wait a week. They said like, okay, quality, great. First rev of that is live, but we now have visibility into what's going wrong. We can't wait another week or 2 weeks or 3 weeks to go upstream and solve these issues, because you see that 85% of their defects are coming from like one station, one problem. And it's like, you can't just sit and watch it happen without going up and solving that. And because you have a highly flexible, adaptable tool, you can go ahead right upstream and say, what's the problem? And it was a matter of how one particular press was setting, right? And so the point is, once you fix that problem, great. Your Pareto is going to shift somewhere else, and there's going to be another problem. To Eddy's point earlier about continuous improvement, but this is the way that these highly adaptable solutions and these platforms allow you to drive incredible efficiencies very, very quickly. So I don't
think,
know.
And to add like another couple more, I think one is around like skills as well, and operator skill level. Like you're able, with the augmented error-proofed solutions, when an operator works up to a terminal I was talking about before to run a process, they're guided through that process. The application can actually error-proof the process for them, so they can't make the wrong decision, can't make the wrong part. One thing that happens there is that they can actually upskill quicker. You can upskill, you can bring in, we have it at Hanover Messe last year, and we'll have something similar this year, where someone walks off the street and is able to make a clock using Tulip without any training and make it something that works. And like we see that as a lever, but I think if you then think of that as a composed system, so can you bring in a signal from the ERP as to what part needs to be produced, or from the PLM as to how the sort of sequence that it should follow or how it should be inspected? You can actually create a dynamic instruction that the operator can follow. So you create the flexibility from being able to train people up quickly and then must move them around the facility to the places where you need them. But you can also create flexibility in the instructions that they're giving, like very quickly deploying a engineering change to the shop floor, for example.
Yeah, and I think that discussion on that connectivity is a great segue into our next question. Right now, there are still silos between what is executed on the shop floor and what ERP BI systems ask for in areas like work order allocation, routing, and goal alignment. Do you think composability and interconnected systems can go beyond the shop floor in the future?
Yeah, I think
that's a great question.
I think they are. Like, the example, very often Tulip is integrated to the ERP. We have a large multinational that I've worked with since I've been at Tulip, and Tulip is the core system for the operator. So the operator doesn't go into their SAP to log the work that they've done or log the consumption of materials. They're doing that by using the composed application that tells them how to make the very luxury good that this company makes, and that's something they've rolled out to thousands of users that are doing this. So they're very much interconnected. The data that's being generated in Tulip is the data that they use to track production every day in their BI systems. So yeah, I think it's happening today and should be the way that companies think about deploying.
Yeah, and to wrap up our Q&A, we'll do this last question. Outside of providing the platform, does Tulip have a WMS, QMS, or maintenance system?
Yeah, great question. So Tulip, what is Tulip? Tulip is the core platform that enables all of the solutions that we talked about, the ability to compose solutions based off of primitives. You can think of it as like the digital Legos for manufacturing. But you don't want to build everything from scratch, and you don't need to build everything from scratch. If you go to our library, this is tulip.co/library, you'll see we've got hundreds of different pre-composed out of the box solutions, that QMS, WMS, yes, and beyond. So if you say, hey, I've got a machine monitoring problem, or a production visibility problem, or a work instruction problem, or to the earlier question, I want to integrate Tulip with S4HANA. You'll see pre-composed solutions in the library that you can, with the click of a button, import into your instance. Go ahead and configure as needed, modify as needed, again using the no code, and then deploy to the shop floor. But another very good question.
And I think what's important here is that this fits very well with the continuous improvement part. It's not, does Tulip have a QMS? I go to the library, I download the QMS, I'm going through this QMS digital transformation process to try and at some point in the future get it in place and hope that I get the savings. It's no, I need defect reporting tomorrow. Right, okay, let's go take the small application for defect reporting, configure it to my needs, and get it running on the shop floor. So back to sort of that first example that Erik supplied. Like these are not big things that you need to try and configure the whole thing. You pull the bit down that you need. Might be you have a warehouse management system and you just want to add on a bit of functionality. You can take that from the library or build that on top of your warehouse management system to give you what you need and really make it fit your process.
Yeah, agreed. And I love that point, Erik. I do think the Tulip library is a great opportunity to kind of explore what's kind of the beginning of what's even possible with Tulip and look at what we provide for you to start building. And with that, that's all the time we have for questions today. So I want to thank our speakers as well as everyone who attended. If you have questions, please reach out directly to the Tulip team. Have a great day, and thank you for joining.